Okay, good morning students. आज का हमारा टॉपिक है, today's topic is AM signal generation by square law modulation method. ठीक है, आज का हमारा टॉपिक है AM signal generation method by using square wave modulator. क्लियर? अब ध्यान दीजिएगा, कुछ पॉइंट्स मुझे आप लोगों को बताना है, ध्यान दीजिए। जो बेटा AM सिग्नल होता है, इसी का एक दूसरा नाम भी मैंने आप लोगों को बताया था, DSB-FC। इसी का मैंने दूसरा नाम भी आप लोगों को बताया था, DSB-FC। सभी को याद है क्या? AM सिग्नल का दूसरा एक मैंने नाम बताया था, AM सिग्नल इज आल्सो नोन एज DSB-FC। व्हाट इज DSB-FC? डबल साइडेड फुल कैरियर। क्लियर है? प्रीवियस लेक्चर्स अगर आप लोगों ने अटेंड किए होंगे तो इस AM सिग्नल की एक्सप्रेशन को मैंने रिप्रेजेंट किया था कि AC 1 plus KA MP into cos of 2 pi FCT। अगर आप लोगों ने प्रीवियस लेक्चर्स अटेंड किए तो वहां पे आप लोगों ने देखा होगा कि मैंने ये सब बताया था आपको। वहां पे हम लोगों ने एक बात और डिस्कस की थी, एक चीज और हम लोगों ने डिस्कस की थी कि दिस KA is known as amplitude sensitivity. This KA is known as amplitude sensitivity and its value is 1 upon AC. This KA is nothing but an amplitude sensitivity and its value is 1 upon AC. What is MT? MT is nothing but a Lenz signal and it is AM cos of 2 pi FC. Okay, so when we combine the amplitude of MT, that is AM. So when we combine this AM with the amplitude sensitivity 1 upon AC, so the combination of these two amplitudes, becomes NA or mu or NA. This term is known as modulation index. We already covered this topic in our previous lecture. Okay, AM upon AC equals to mu. It is also known as modulation index of AM modulation. Okay, so on the basis of this AM, on the basis of this MA, that is modulation index, or we can say mu, on the basis of this MA, we can say there are the three different type of amplitude modulation. I repeat, on the basis of this modulation index, है ना, हमेशा ध्यान रखिएगा, amplitude modulated signal को दो टाइप्स में डिवाइड कर सकते हैं, on the basis of its structure, carrier structure वगैरह, और on the basis of its frequency, and the second one is on the basis of modulation index. Clear, right? So when we divide amplitude modulated signal on the basis of this modulation index, so there are the three different type of amplitude modulation. One is known as under modulation, second one is known as critical modulation, and the first one is known as over modulation. We already covered this topic in our previous lecture. Okay, so यहाँ पर मैंने बताया था when value of AM equals to AC, when value of AM equals to AC, so at that time this MA becomes 1, MA equals to 1. So when MA equals to 1, so this type of AM modulation is known as critical modulation. Is it clear to all of you? Now, when the value of AM is greater than AC, when the value of AM is greater than AC, so at that time this MA becomes greater than 1. When the numerator is greater than denominator, so we can say at that time the modulation index will be greater than 1. So when the modulation index is greater than 1, at that time this type of modulation is known as over modulation. This type of modulation is over modulation. Okay, इसका structure भी मैंने आपको बताया था. How can we draw over modulated signal? How can we draw over modulated signal? We can draw over modulated signal as like this. We can draw over modulated signal as like this. पता है ऐसा कुछ हम लोगों ने बताया, तो बीच का ये वाला जो एरिया था मैंने बताया था, ये वाला जो एरिया होता है जहाँ पे हमारी when the positive oscillation mixes with the negative oscillation, so at that time this type of distortion is known as phase reversal. This type of distortion is known as phase reversal. Okay, we already discussed this. Now, when the value of AM is less than AC, when the value of AM is less than AC, when the value of AM is less than AC, so we can say when the numerator is less than denominator, so at that time this MA becomes less than 1. So this MA becomes less than 1. So when the value of MA becomes less than 1, so at that time this type of modulation is known as under modulation. At that time this type of modulation is known as under modulation. इसके लिए हम लोगों ने कुछ इस टाइप की diagram में draw किया. ये हम लोगों ने सब अपने प्रीवियस लेक्चर में ये सब डिस्कस किया है। क्लियर बात है? ठीक है, जस्ट मुझे एक रिकॉल कराना था, ये हम लोग सब लोग ने डिस्कस किया है। आज के लेक्चर में हम लोग देखेंगे जनरेशन ऑफ एएम सिग्नल। क्लियर बात? आज के लेक्चर में हम लोग देखेंगे जनरेशन ऑफ एएम सिग्नल। So when we generate AM signal, when we generate AM signal mathematically, so at that time we try to find out the mathematical expression of AM. This one is the mathematical expression of AM. So when we try to generate AM signal, so at that time we try to form this mathematical expression. Okay, so हमें एडवांस में क्या करना है, ये वाला मैथमेटिकल एक्सप्रेशन फाइंड आउट करने की कोशिश करना है और कुछ नहीं। क्लियर बात? सो इसका एक मैथमेटिकल एक्सप्रेशन फाइंड आउट करने के बहुत सारे मेथड होते हैं। तो जितने भी मेथड होते हैं उन्हें हम क्या कहते हैं? जनरेशन मेथड ऑफ एएम सिग्नल। क्लियर बात सभी? ठीक है, तो जितने भी टाइप के एएम जनरेशन मेथड होते हैं बेटा, जितने भी टाइप के एएम जनरेशन मेथड होते हैं, उन एएम जनरेशन मेथड में से एक है और बहुत ही इंपॉर्टेंट है। बहुत सारे एक्चुअली होते तो बहुत सारे हैं, आपके सिलेबस के पॉइंट ऑफ व्यू से मैं बता रहा हूं। उनमें से एक मेथड होता है जिसे हम कहते हैं स्क्वायर, जिसे हम कहते हैं स्क्वायर लॉ मॉड्यूलेटर। स्क्वायर लॉ मॉड्यूलेटर याद रहेगा सभी को? सभी को ध्यान रहेगा? दिस वन इज द मेथड दैट इज यूज्ड टू जनरेट एएम सिग्नल। This one is the method that is used to generate AM signal. Is it clear to all of you? Okay. Now the block diagram of this square law modulator is shown below. The block diagram of this square law modulator is shown below. First we need an adder. So when we consider adder, it means that we have two types of signal which is added by the adder. So here I am taking one signal as ND and the second signal as CT. So when we add this message signal with the carrier signal, so we will get the addition of message signal with the carrier signal. Is it clear? Is it clear for you? Now we provide this addition to the non-linear device. To the non-linear device. To the non-linear device. Now, what is the meaning of non-linear device? Non-linear device is that which follows the non-linear characteristics. Non-linear device is that which follows the non-linear characteristics. Suppose I am considering Ohm's law equals to I. Suppose I am considering Ohm's law equals to I. If you draw its characteristic with respect to V and I, so it becomes linear. Okay, जैसे V और I के respect में अगर मैं I की characteristic draw करता हूँ तो on the basis of this expression we can say the characteristic become linear. Okay, but if I draw a characteristic like this, this one or this one. If I draw the characteristic between two variables like this one or this one, so we can say here the characteristic is non-linear. What is the meaning of non-linear? Non-linear means if we increase the variable in x-axis, so the y-axis is not increases proportionally. Okay, so this type of characteristic is known as non-linear characteristic. This type of characteristic is known as non-linear characteristic. This one is the positive nonlinear characteristic. This one is the negative nonlinear characteristic. Okay, so for getting this type of nonlinear characteristic, we can use several devices. We can use several elements. Out of them, here we can use our element known as diode. Here we are using our element known as diode. In this place, because this diode has a non-linear characteristic. Okay. Now the output of non-linear characteristic is provided into the band pass filter. Now this is provided in the band pass filter. Now what is band pass filter? Band pass filter is nothing which is responsible to pass only a certain band. Okay, so it means that if I am making a band pass filter with center frequencies Fc and lower frequencies Fc minus Fm and the highest frequencies Fc plus Fm, it means that this type of filter only passes the frequency that lies in this range, that is Fc minus Fm to Fc plus Fm. Okay, if I am making a band pass filter which is tuned to frequency FC and whose lower frequency is FC minus FM and highest frequency is FC plus FM. So it means that this type of band pass filter only responsible to follow, only responsible to pass the frequency which lies in this range only, FC minus FM to FC plus FM. Okay, now at the output of this band pass filter, now the output of this band pass filter, you will get the modulated signal S2. You will get this modulated signal S2. Is it clear? जल्दी से ब्लॉक बना लीजिएगा, जल्दी से ब्लॉक डायग्राम बना लीजिएगा. If you want to implement square law modulator, so this one is the block diagram of square law modulator. It means that square law modulator consists of 3 different devices. One is adder, second one is the non-linear device, and the third one is the band pass filter. But जल्दी से आप लोग इसे ड्रॉ कर लीजिएगा. ठीक है, ये स्क्रीनशॉट वगैरह ले लीजिए. चलो now the diagram of this square law modulator. Here, this one is the massive signal entry. This one is the massive signal entry, and this one is the carrier signal CT. This one is the carrier signal CT. If you combine these two signal into series, it means that these are added. Okay. So मैंने दोनों सिग्नल को सीरीज में रिप्रेजेंट कर दिया है. Now here I am taking a non-linear device. We can take diode here, which follows the non-linear characteristic. Okay. Now the third one is here I am taking a band pass filter. Okay, this one is the capacitor, this one is the coil, I'm using this resistance, this one is the resistance in the transformer. By using this, we are making a band pass filter. So this one is nothing but a band pass filter. This one is band pass filter, BPF. Okay, now where we get modulated signal. Now, in this end, we will get the modulated signal ST. This one is the non-linear device. This one is the NLD, non-linear device. Here I am taking that as a non-linear device. We can represent it as D1. Okay. This one is the massive signal. This one is the carrier signal. I am representing its polarity here, plus minus. If I am representing its polarity, plus minus, so at that time this will add it. If I will change this polarity, so at that time these two signals will suppress each other. Okay. Now the combination of this massive signal and the carrier signal is represented as PN. Okay. So this one is the diagram of this square law device. Now this one is the diagram of this square law modulator. Okay. Why we use this square law modulator? Square law modulator is used for generation of AM signal. Okay. Here we will get AM signal. Here in the output we will get AM signal. Is it clear? Here in the output we will get AM signal. In this side we will get the AM signal. That side. Okay. Now I am representing a mathematical expression. For this square law device. For this, first I will take a massive signal. We know that massive signal is represented by NT, and we can write this NT as AM cos 2 pi FMT. We can write NT equals to AM cos 2 pi FMT. And we know that the equation for the carrier signal becomes AC cos of 2 pi FCT. The equation of carrier signal is AC cos 2 pi FCT. Okay, so now, first what we have to do? First we have to add this massive signal to the carrier signal. Okay, so when we add this massive signal with the carrier signal, so what we will get? We will get the VI. What we will get? VI. So we can represent when when we add these two signals, we add these two signals, when we add these two signals, when we add these two signals, when we add these two signals, so what we will get? We will get VI. What we will get? We will get VI. And this VI becomes NT plus CT. This VI becomes NT plus CT. Is it clear to all of you? Now, this VI signal is provided as an input. Now, this VI signal is provided as an input to this nonlinear device. As I mentioned previously, nonlinear device is that which follow the nonlinear characteristic. It means that if the input is VI, and the output is V0, so there is nonlinear relationship like that. AVI plus BVI is equal. It is the nonlinear relationship. If I write, instead of this, if I write V0 equals to AVI, so it is the linear relationship. Here, the relationship between the output voltage and the input voltage is linear. Okay, but this one is the nonlinear device. That's why I have to follow this nonlinear equation. समझ में आया सभी को? It means that if I consider the output of this diode as V0 and the input of this diode as Vi, so we can write the expression for output of nonlinear device as. We can write this expression as equation number 1. Now, we can write this expression as equation number 1. Now, we can write, now, the output of diode, V0 equals to, now the output of diode, V0 equals to AVI plus BVI whole square. AVI plus BVI whole square. Is it clear? AVI plus BVI whole square. Here, VI is the input voltage that is provided to the nonlinear device. Is it clear? Okay. So by using equation number 1, by using equation number 1, we can write. Equation number 1 का यूज करके क्या हम मेंशन कर सकते हैं? By using equation number 1, we can write V0 equals to, ठीक है, इसके बाद में ऊपर लिखता हूँ, क्लियर है यहाँ तक सभी को? ठीक है, by using equation number 1 we can write, what we can write? By using equation number 1 we can write V0 equals to A, and instead of this Vi we represent equation number 1, instead of this Y we represent equation number 2. Okay, so by using equation number 1 we can write A into NT plus CT, okay, and B into NT plus CT whole square, NT plus CT whole square. Is that clear? NT plus CT whole square. Is that clear to all of you? Now I am only putting the value of the CT here. So when we put the value of CT in this equation, so what we will get at the time, we will get A into NT. We put the value of CT here. So what we can write here? We can write AC cos of 2 pi FCT plus B into NT plus AC cos of 2 pi FCT whole square. Is it clear to all of you? Now, at last, I will provide this expression to the band pass filter, which is tuned to the frequency FC. Okay? Otherwise, no support mid-arm. At last, we will put this expression to the tuned band pass filter, which is tuned to the frequency FC. Now, after solving this expression, we can write this expression as A into NT plus A into AC cos of 2 pi FCT plus B. अब यहाँ पे देखिएगा, we have to put A plus B square formula here. A plus B square equals to A square plus 2ab plus b square. A square plus 2ab plus b square. A means m square t. 2ab means 2mp into AC cos of 2 pi FCT 2mp AC cos 2 pi FCT plus AC plus AC square cos square 2 pi FCT. Is it clear? Is it clear to all of you? मैंने यहाँ क्या किया? Is it clear to all of you? We only put the expression of a plus b square here. Okay. Now, when we insert this constant value inside the bracket, so here it becomes b 2b mt and it becomes b ac square cos square 2 pi fct. Is it clear to all of you? Now, the expression becomes a into mt. Now the expression becomes a into mt plus a into ac cos of 2 pi fct b into m square t this b into m square t plus 2 mt into b into ac cos of 2 pi fct plus यहाँ पे देखिए here it looks like the cos square theta. So value of cos square theta is 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. Okay. So it becomes a into mc 1 plus cos 2 theta by 2. So it becomes 1 plus cos 2 theta. So it will be cos 4 pi fct. So it will be cos 4 pi fct. So it will be cos 4 pi fct. Okay. Now this we can represent this expression as we will represent this expression as equation number 2. We will represent this expression as equation number 2. Now this expression is provided as an input to the band pass filter, and we know that band pass filter is tuned to frequency fc minus fm to fc plus fm, and the fc frequency is inside this range. Okay, and we know that this message signal is very messy as compared to fc, so the message frequency is in the outside of this range. Okay, if we will get 2fc, so 2fc frequency is also outside in this range. सभी को समझ में आया? Band pass filter is that which is responsible to pass only the tuned frequency. And here our band pass filter is tuned to fc minus fm to fc plus fm. That's why it passes only the frequency that lies in this range. If the frequency lies outside this range, it means that if the frequency is 2fc, 3fc or 4fc, so it will not pass us. And if the frequency is less than this fc minus fm, also it will block in this range. Okay, now we will try individual terms. First we will take this term. First we will take this first term. सभी यहाँ पे ध्यान दीजिएगा. First we will take this first term. Here first term is a mp, and we know that mp is nothing but the am cos of 2 pi fmt. It means that the frequency of this mp is fm. And this fm is not in the range of this band pass tuned filter. Okay, so it means that it will not pass us in the output side. So we will cancel it. We can cancel it. Okay. Now the second term. What is the second term? A into fc. Now this one is the second term. Its value is a into fc cos 2 pi fct. Its frequency is fc. And we know that its frequency lies inside this region. It means that it will pass us in the output side. Is it clear to all of you? Now, if I am taking this third term, If I am taking this third term, if I am taking this third term, here I am taking m square t. M square t, it means you know that m is the frequency of m is fm. So if I am taking fm square, it means that cos is equal to pi fm t. So when we mathematically when we solve this equation, so what we will get? 1 by 2, 1 by 2, 1 plus cos 2 theta. So what we will get? Here we will get the frequency 2fm. This 2fm frequency, this 2fm frequency is not in the range of this band pass filter. So we can also cancel it. If here this frequency 2 MP BAC cos 2 pi fc. Here there are the two different frequencies. One is the FM and one is the FC. Here there are the two different frequency components. And we got this frequency component in the multiplication with each other. So after multiplication, what we will get? We will get cos A cos B formula here. So when we apply cos A cos B formula here, so according to cos A cos B to cos A cos B, we will get cos A plus B plus cos A minus B. Cos A plus B means we will get the frequency Fm plus Fc. We will get Fm plus Fc, and another time we will get the different frequency Fm minus Fc. We get two different frequencies here. One is Fm plus Fc, and another one is the Fm minus Fc. And we know that both these frequency lies inside this result. It means that this one will pass out from the band pass filter. Is it clear? Now this BAC square by 2, BAC square by 2, BAC square by 2. BAC square by 2 into m. Here there is no frequency component. Here there is no frequency component because this one is the amplitude, this one is the constant term, this one is the constant term, this one is also constant term. So this one is not passed with the band pass filter. And here the second term is 4 pi fct, or 4 pi fct. So when we try to find out the frequency component, so frequency component here is 2 fc, which is very much greater than the which is very much greater than the band pass filter. It means that it is passes with the band pass filter. So how many frequency band passes with the band pass filter? Only the first, only this one and then this one. Okay, so when this mathematical equation, when this mathematical expression is provided to the band pass filter, so after band pass filtration, what we will get in the output side? We will get A into AC. What we will get in the output side? A into AC cos 2 pi fct plus, here we can write A 2 and P into B into AC into cos of into 2 pi fct. Is it clear to all of you? How many components we can consider as a common element? We can take AC as a common element. We can take AC as a common element. We can take AC as a common element. So when we consider AC as a common element, so what we will get? We will get A. Okay. We consider AC and cos 2 pi fct as a common element because it lies in both the expression. So when we consider, so what we will get? We will get A from the first term, and what we will get? We will get 2. We will get 2 into B. What we will get? 2 into B. This one and this one. 2 into B. Because empty. We will get 2 into B and empty. We will get 2 into B. And the rest of cos 2 pi fct we can find in the opposite side. ओके मैं इसको एक बार और ठीक से लिख रहा हूँ ना, मैं इसको एक बार टॉप पे लिख रहा हूँ, शायद ब्लैक बोर्ड में आप लोगों को दिख नहीं रहा होगा ना, मैं इसको एक बार टॉप पे लिख रहा हूँ, ध्यान दीजिएगा, मैं इसको एक बार टॉप में लिख रहा हूँ, एक बार ध्यान दीजिएगा सभी, है ना? The expression of this modulated signal, what we get? V naught equals to AC A into 2B, A into 2B. This one is empty. A into 2B empty. Bracket close. Then in the output side, cos of 2 pi fct. Is it clear? After passing the signal with the band pass filter, what we will get? We will get this. We will get this above expression. we will get this above expression. Is it clear to all of you? Now, if I consider this A as a common element, when we consider this A as a common element, and we will put A into AC here. So what we can write A into 1 plus 2 2B upon A into MT into cos of 2 pi into FCT. Is it clear to all of you? Is it clear to all of you? Now this one is the final expression. Now this one is the final expression that we will get from the square law modulated circuit. And this one is the final expression that we will get from the output of square law modulated circuit. And we already know that from our previous study. We already know that from our previous study that this V naught, the expression of wave signal is what we already discussed, that the expression of wave signal is ST equals to AC 1 plus K into MT in bracket close into cos of 2 pi FCT. Is it clear? Is it clear? Now what is this K? K is nothing but 1 upon AC. Is it clear to all of you? Is it clear to all of us? Now, if we look carefully, this expression, equation number 3, we can represent now this final expression as equation number 3. We can represent this final expression as equation number 3. And if we compare this expression, equation number 3, with the amplitude modulated equation that we already discussed in our previous lecture. If we compare these two expressions, so we can say here 2b upon A is written instead of 1 upon AC. So we can say this 2b upon A is 1 upon AC. So we can write it as amplitude sensitivity. Is it clear? Because 1 upon AC is amplitude sensitivity K. 1 upon AC is nothing but a K. So instead of this 1 upon AC, here 2b upon A is written. So we can say this 2b upon A is a Ka. Is it clear to all of you? Here 2b upon A is the K, and this one is the final expression. This one is the final expression that we will get. This one is the final expression that we will get from the outside of the amplitude modulator. Okay, this one is the final expression that we will get is the output of amplitude modulator. You can write here 2b upon A. Here 2b upon A is the Ka, which is amplitude sensitivity. Okay, this one is the carrier, this one is the mass. This one is the final expression that we want to extract from the circuit. ओके, आई थिंक सभी को समझ में आ गया होगा आज का टॉपिक। आई थिंक सभी को समझ में आ गया होगा आज हमने क्या पढ़ा। आज हमने पढ़ा बेटा स्क्वायर लॉ मॉड्यूलेशन, एम्पलीट्यूड मॉड्यूलेटेड सिग्नल जनरेट करने का मेथड है ना। बहुत सारे मेथड होते हैं एम्पलीट्यूड मॉड्यूलेटेड सिग्नल जनरेट करने के, उन्हीं में से एक मेथड था स्क्वायर लॉ मॉड्यूलेटर मेथड। ठीक, तो आज की क्लास में हम उसे ही डिस्कस करना था। तो आई थिंक ये कंप्लीट हो गया और आप लोगों को समझ में आ गया। ठीक, किसी को भी इसमें से कुछ डाउट है तो आप लोग पूछ सकते हैं। जितना भी मैंने बताया कुछ डाउट है तो पूछ सकते हैं। एक बार सबसे पहले चैट बॉक्स में आप लोग अपना नाम मेंशन कर दीजिएगा कितने लोग क्लास अटेंड कर रहे हैं। एक बार चैट बॉक्स में सभी अपनी अटेंडेंस कर दे दीजिएगा। और किसी को कुछ डाउट है तो तभी आप लोग साथ में पूछ सकते हैं। ठीक है, नहीं तो आज की क्लास यहाँ पे कंप्लीट करेंगे। ठीक, दीपेश है, नम्रता है, किसी को भी कुछ भी डाउट होगा बेटा तो आप लोग पूछ सकते हैं। आयुष, गंगाधर, ईशा, अनिकेत, है ना, सभी लोग इसका स्क्रीनशॉट ले लेंगे। जब भी आप लोग क्लास आने स्टार्ट करेंगे सभी की कॉपी में पूरे नोट्स होने चाहिए। जितना भी अभी तक हम लोगों ने कैलकुलेट किया है, जितना भी पढ़ा है, सभी की कॉपी में पूरे होने चाहिए। अनिकेत, अभिषेक, ईशिका, प्रेरणा, अनुराग, नवतेज, 1 2 3 4 5 6 7 8 9 10 11 भूमिका, आयुष, हिमांशु, 12, 13, 14। ठीक है बेटा, आज की क्लास यहाँ पे कंप्लीट करते हैं। अगर आप लोगों को कुछ डाउट है तो आप लोग पूछ सकते हैं, अदरवाइज आप लोग क्लास लीव कर सकते हैं। थैंक यू सो मच।